I am going to kind of start over. Don't mind me. Okay, our LCD is 18. 18 is your biggest number. It doesn't simplify. 9 can turn into 18. 2 can turn into 18. So 18 is our LCD. Now, before we keep going here, let's look at our domain. We talked about domains before, but it's been a while. Okay, domain is when your letter can't equal something because it's okay to have a 0 on top, but remember, it's not okay to have a 0 on bottom. Yeah? So you can honestly just look at your LCD to find your domain. Well, are there any letters here? Are there any letters in your domain? I mean your domain. Your denominator. No. So we don't care what our variables are because there are no variables in the denominator. So your domain is all real numbers on this one. However, if you look here, we have variables, so it's not going to be all real numbers. That's only when there's only letters in the denominator. Yes? Okay. So knowing that, now we can keep solving. Well, I'm going to kind of show more work on this one, and on the other ones I'm going to kind of skip some steps because it'll make more sense, but I want to show you why on this one, and then on the other ones we'll already know why, so we'll just cross it out kind of thing. Yes? Okay. So knowing that, I'm going to rewrite this, and I have 9 times t minus 4, and that's over 18, minus 2 over t minus 3, also over 18, equals 5 over 18. Now we know that when we have an equal sign, whatever we do on one side of the equal sign, as long as we do it to the other, it's still equal, correct? Well, what is division? Well, I mean, sorry, dang it, I answered my question. Fractions are just division, yes? How do you cancel division? Multiplication. So I know that if I multiply, now that I have a common denominator, both sides by 18, well, this side, the multiplication cancels the division, and I just have 5 left. Yes? And on this side, well, you distributed the 18, well, it cancels the denominator, so you're done. That's it. It just cancels the denominator. So when you have a common denominator, y'all, you don't have to show me that step. You can just cross them out. And this is why. Yes? It's because if you were to have multiplied, they would have canceled. Yeah? Okay, so knowing that, I'm going to rewrite the top. And again, you could have kind of skipped this step. Goodness gracious English. Okay. But I'm showing you all the steps so we understand. So now we have to solve.
Is that going to 96?
No, it canceled the denominator because multiplication cancels division. So now we have to simplify. So we're going to distribute. 9 times t is 9t. 9 times negative 4 is negative 36. Now, do you remember how we had this minus here? If you remembered when we did expressions, we had to always bring it up so we wouldn't forget it. So if you went from here to here, you would have had to make sure you brought that negative up. Yes? Okay, so negative 2 times t is negative 2t, and negative 2 times negative 3 is positive 6, equals 5. Now, we like this problem because there's no t squared, which means we do not have to factor, so we're just combining like terms and then solving for t to get our answer. No factoring. Okay, so we're going to combine our like terms. So we have 9t minus 2t, which are alike, and that gives me 7t. And then we have negative 36 plus 6, which gives me negative 30, equals 5. How do I solve that? Add 30 to both sides. Remember, we want to get t by itself. So we have 7t equals 35. And we're going to divide both sides by 7. And we get t equals 5. Now, we said our domain is all real numbers. 5 is a real number, so t equals 5. There's our answer. Any questions with this? So we like that one. We didn't have to factor. You could have skipped from here to here, and I'm going to kind of show you that on the next two, or the next couple, but I wanted to show you kind of the why on those two steps. Yes? Okay, look at number 2. When you have binomials as your denominators, you're just multiplying the binomials if they don't match. Now, what if they already match? Could you just cross them off and solve the top? Yes. But these don't, so we're going to do x plus 2x minus 5 And now that's two factors, one factor, two factor, that both have variables. So what can x not equal? Well, what gets rid of a positive 2? What makes that equal 0? Negative 2, yeah. And then what gets rid of a minus 5, a negative 5? Positive 5. So those are your limitations on your domain. X cannot be negative 2 or positive 5 because that would make your denominator equal 0. Okay? And remember, it's okay to have a 0 on top. It is not okay to have a 0 on bottom. Okay? No. So knowing that, I'm going to kind of show you the cheater method to solving this one. You don't actually have to multiply on this one because, do you see how I only have two fractions and a 0? What does a 0 represent? Nothing. Okay, there's no number. It doesn't represent anything. So it's still a number. I know I said no number. It's still a number. It doesn't hold value. So when we move this, if we were to set one fraction equal to the other, you could cross multiply and solve, which makes life easier. Okay, so knowing that, if I moved this, how do you move a minus? Yeah, you do the opposites of plus. So if I added 6 over x minus 5 to both sides, this zeroes out technically, and I get 7 over x plus 2 equals 6 over x minus 5. Now I'm going to kind of show you my cheater method. If it equals 0, y'all, minus, the opposite of minus is positive, so if I just made this an equal sign and cross that out, is that the same thing? Yes. Okay, now if you did it this way, it doesn't matter. But if you can make it a fraction equals a fraction, even by adding, you'll just have a negative. It's not a big deal. Or subtracting, sorry, we did add. Subtracting, you'll just have a negative. It's not a big deal. But you can do cross multiplying and make your life easier. So here we cross multiply and we get 6 times x plus 2 equals 7 times x minus 5. Now, it's still important to find your common denominator and your domain, because what if we solved and one of our answers was negative 2 or 5? Well, didn't we say that's what x cannot equal? So you'd have to cross those out. So you still have to find these two things. Yes? Okay. So we solve, and we get 6x plus 12 equals 7x minus 35. I always like to move my smallest x first when I get to this point. So minus 6x minus 6x. And that leaves me with 1x or just x. And then I'm going to add 35. So if you did the other method, you will get the exact same answer. And you get x equals 47. Well, 47 is not negative 2, and 47 is not 5. Therefore, this is your answer. So again, we liked those two because there was no factoring. However, look at number 3. Something we like about number 3 is that, yeah, there's only one fraction, but what is the denominator of that one fraction? Therefore, that's your LCD. Okay? And what can my denominator not equal? 0. So x cannot equal 0. Well, if this is a denominator of x, I need this to be an x. Whatever I give to the bottom, I have to give to the top. You can put a 1 there and technically multiply, but 1x is just the same thing as x, correct? So you don't have to put the 1 if you don't want to. So if I give the bottom an x, I have to give the top an x, bottom, top. Do all the denominators match? Therefore, I can cross them out. And I'm left with 3x minus 6 equals, what's x times x?
X squared.
X squared plus 8x. Now this one's different from the last two because now I have a squared. Meaning to solve this one, I'm going to have to factor. So when you have something squared, a letter squared, you have to get it equal to 0. You're no longer solving for x. Okay, so I need to move, my x squared is positive, so I'm going to leave it. Don't move it. I'm going to move everything on the other side over to join it because I don't want a negative x squared. Yes? You can't factor when there's a negative x squared. So minus 3x And I'm going to move both of them at the same time to make my life easier. Plus 6, there is no like term, so I'm just going to add it to the end. Plus 6. And I get 0 equals x squared plus 5x plus 6. Is everybody okay with that? Are there any questions with that? Oh, I think I just drew on my chat. That's fine. No, okay. So I have A, B, C. A is 1, B is 5, C is 6. I'm going to kind of show more work on this one since it's our first factoring since break. Remember, on the top of your x is A times C, the bottom is B. So A times C is 6, B is 5. What multiplies to give you 6 and adds to give you 5? 2 and 3. Positive 2, positive 3. Everything here is positive, y'all, so everything's going to be positive here. Don't make your life hard. Now, A is 1, so do we have to do the box? No, so we get 0 equals x plus 2, x plus 3. Your answer is not 3 and 2, so be super careful. This is the same as when we solved by factoring. Okay, so remember you separate and you set equal to 0 and solve. Death by door. Thank you. Okay, so we're going to subtract 2, x equals negative 2, subtract 3, x equals negative 3. And remember, we always write least to greatest, so negative 3 comma negative 2. When there's multiple, I like to use fancy brackets. If you just left it as x equals, that's fine. Neither of those were 0, so we're good. The domain didn't matter really there. Yes? Okay, so flip to the back when you're done writing that down. Huh? So close, yet so far. I'll put it back up in a minute. Okay, look at number 4. Okay, one thing I want you to notice with these is that 2 of them already match. Yes? That does not mean write it twice. It already matches, okay? If you write it twice, you're giving yourself way more work than you need to. Don't do that to yourself, yes? Okay? You're going to be like triple distributing. We already don't like double distributing. It's going to even technically be more than that. Don't do that to yourself, yes? Okay, so we know that we already have an x minus 2 that matches. And then what does that other one have that these two don't have? The x plus 2. So there is your LCD. Whoa, there's a staple, so that was a little crazy, parentheses. So find our domain. What can x not equal? Well, what would cancel a negative 2? And what would cancel a positive 2? So negative 2 or positive 2. So I need to make sure all of my domains are x minus 2, x plus 2, or x plus 2, x minus 2. Order doesn't matter with multiplication. Okay? So this already has the x plus 2. What does it need? X minus 2. I don't like this one. This one's probably the worst one, so bear with me. It's just a lot of multiplying. It's not hard. It's just kind of long. Okay? This one already has the x minus 2. What is it missing? The x plus 2. This one has the x minus 2. It's missing the x plus 2. Okay, do all of our denominators match now? They all have the x minus 2, x plus 2, so we can cross them off. Which we like doing. And now we have to distribute. So that first one is single distribution, which is nice. X times x is x squared. X times negative 2 is negative 2x. Now, what sign do we have in the middle? Negative. And that kind of makes this one weird because you have to distribute that negative. Now, if you look at number 1, we had a negative, but we put a 2 in front, which was a single term. So you could just put it in front and it was fine. However, these both have 2 terms, so we can't do that. So I like to distribute it first and not later because if you forget, then you have the wrong answer. So I'm going to distribute this negative, and I get negative x minus 2. And then I'm going to cross off the negative because I've distributed it and I don't have to worry about it now. Okay? So now I'm going to double distribute these guys, but with the negative x and the minus 2, not the positive x, positive 2. Because I had to give that negative to everything after this symbol. So negative x times x is negative x squared. Negative x times 2 is negative 2x. And now I have to distribute that negative 2. Negative 2 times x is negative 2x. Negative 2 times 2 is negative 4. I know, I told you, this one's just long. It's not necessarily hard, it's just gross. Okay, equals, double distribute one more time. X times x is x squared. X times 2 is 2x. 3 times x is 3x. And 3 times 2 is 6. Okay, the worst if it's ever. I told y'all this one was gross. I wasn't lying. We're going to simplify both sides before we start trying to move anything. My word of advice, though, is I have a lot of people that will start trying to add like terms before they even finish multiplying. Finish one thing at a time. If you're multiplying, finish multiplying all the way across before you start trying to simplify, because you're going to start losing yourself and you're not going to remember what you've done and what you haven't done. Yes? Cool. Okay, so I have an x squared minus x squared, which gives me what?
0.
Yeah, they cancel. Cool, cross them out. Then I have a negative 2x minus 2x minus 2x. Negative 6x. Yes, they do not cancel because they're all negative. You have to have a positive and a negative to cancel. And then I have to bring down my minus 4 equals, what are my like terms on the right? Yeah, the 2x and the 3x. So I get x squared plus 5x plus 6. Do I have a squared? Yes, so I have to factor, which means I may need to make it equal 0. So plus 6x plus 6x plus 4 plus 4. And I have 0 equals x squared plus 11x plus 10. This ugly one is almost over. What's a times c? Yeah, 1 times 10 is 10. And what's b? 11. And everything's positive, so these are both going to be positive. What multiplies to give you 10 and adds to give you 11? 10 and 1. So we get x plus 10. I'm going to set it equal to 0, and x plus 1, set it equal to 0. We don't have to do the box because a is 1. Well, these are super easy to solve. What's the opposite of plus 10?
Negative.
What's the opposite of plus 1? So there's my answer. Are either of those negative 2 or positive 2? So there's my answers. And remember, you should be writing them least to greatest. Okay, the next two are not as bad. You do have to do the box on number 5, but it's way less work than that one. Yeah, that was like the one we don't like. Okay, so if you look at number 5, remember, to find your LCD, you have to make sure all of your denominators are factored. So, which one's not factored? First, second, or third?
First.
The first. What can I do to this one?
Take out 3.
Yeah, take out 3, which is my GCF. And when I take it out, I'm left with x minus 2. So, looking at the 3 denominators, what matches already?
X minus 2.
Yeah, the x minus 2. So I know that's going to be part of my LCD. So I have these x minus 2s. Now I also have a 3 and a 6. The 6 cannot simplify. 5 over 6 doesn't simplify. But can 3 turn into 6? So 6 is a part of my LCD also. So again, we have 2 factors. This doesn't have a letter, so does it matter when it comes to domain? No, so we can cover it up. What would make x minus 2 equal 0? Positive 2. So x cannot equal positive 2. And now we make all of our denominators match. How would I turn this into 6x minus 2? Well, I have a 3x minus 2. How do I turn that 3 into a 6? Times 2. So top and bottom times 2. This already has this 6, so it needs the x minus 2. So I'm going to multiply top and bottom by x minus 2. This already has the x minus 2, so it needs the times 6. So I'm going to multiply top and bottom by 6. Now are all our denominators 6 times x minus 2? Yes. So what do I do when my denominators match? Cross them out. Okay, and now I've simplified the top, so I'm going to multiply. What's 2 times x? 2 times 1. Bring down your equal sign. 5x times x. 5x times negative 2. Don't forget your x. And then plus 6 times 1, which is just 6. Okay, so now, I know, but do you see how this one, like I said, has less work? We have to do the box, I know, but it's not that bad. So minus 2x minus 2x minus 2 minus 2, and with 0 equals 5x squared minus 12x plus 4. So I'm going to come back to the top when I do the box because I don't want to take up all my room so I can keep solving. Now, a couple reminders with the box. Remember, your first term goes in the first box, last term goes in the last box, and you're always going to put an x or whatever variable you're using in those two boxes. Now we have to do the x. Sorry, I don't know what I was about to ask. So what's a times c? What's 5 times 4? And what's b? Okay, when you have a positive on top and a negative on bottom, y'all, that means it's going to be a double negative. What multiplies to give you 20 and adds to give you 12? Forget the negatives for right now. It's simpler than y'all are making it. No. That would do 9. What's half of 20? How many times?
2.
What's 2 plus 10?
12.
What's 2 times 10? Look at us go. Okay, were you making it harder than you needed to? Somebody's really popular over here. Okay. So this is what we have. Now, a couple reminders. You're always going to have a variable here and here. And see how this is minus and this is minus? That's telling you that you're going to subtract. What if one of them was plus? Then you would add, right? Yeah, go ahead and go here too.
Is that my AP?
Yep. She wants to say hello.
What does she call me to?
I don't know.
My mom called me?
Oh, what did you do? Have so much fun.
I'm not going to have no fun.
We love you. Be good making choices. Okay, so does 2 go into 5? No. What else goes into 2? 1 or just x. So 1x or just x. Does 4 go into 10? No. What else goes into 4?
2.
Does 2 go into 10? Yes. Does 5 go into 10? Yes, so 5 is my GCF. Does 2 go into 4? Yes, so 2 is my GCF. So I have x minus 2, 5x minus 2, and then remember you separate and solve. So x minus 2 equals 0, 5x minus 2 equals 0. Well, plus 2, x equals 2, plus 2, 5x equals 2, and then what happens? Divide by 5. And you get 2/5. Well, what's wrong with one of those answers? Didn't we say x cannot equal 2? So this cannot be our solution. Now, don't forget it all the way. We know 2/5 is an answer. So you're going to write 2/5, and then what you do with that answer that doesn't work is you put it in parentheses. So that's your solution that doesn't work. There's a word for it that we'll talk more about later. Okay, last one. Well, okay, here's one more question I wanted to say. What if this 2/5 wasn't an answer? What if 2 was the only solution I got? And then it said, well, x can't be 2. So we would say no solution, parentheses, 2, parentheses. Does that make sense? It's okay to be no solution. And I'm going to show you kind of what happens. So this is a special case. I'm going to factor it for us to kind of save time. Okay, what do you think your LCD is here?
X minus 6.
Yeah, x minus 6, x plus 3. So what can x not equal?
6 and negative.
Yeah, 6 and negative 3, so right at least to greatest negative 3 comma 6. Because it's opposite. Okay, this already has both, so that does not change. That's going to stay x plus 39. This has x plus 3, so it needs the x minus 6. Don't forget to bring up that negative. I'm going to cross it out because I brought it up. This needs the x plus 3. Do all my denominators match? I was about to say GCFs, but that's not what they are. All my denominators have the x minus 6, x plus 3, so we're going to cancel them out. And we're going to simplify the top. So 5 times x is 5x. 5 times 3 is 15. Negative 4 times x is negative 4x. Negative 4 times negative 6 is positive 24. Well, if I combine like terms on the left, I have 5x minus 4x, which gives me x, and I have 15 plus 24, which gives me positive 39. What do you notice? They're the same. If you were to try to solve this, you would do, well, minus x, they're both the same, they both zero out, and you get 39 equals 39. Does that mean 39 is your solution? No, because if 39 was your solution, it would say x equals 39. Does this say x equals 39? There are no x's. So what's your answer? It's a special case. Is this true or false? Does 39 equal 39? Yes, so when it's true, what's your answer? There's two options for special cases. All real numbers or no solution. So when it's true, what do you think it is? All real numbers. However, what numbers can it not be?
Negative 36.
So all real numbers except negative 3 and 6. If you wrote your domain, I won't take off if you don't write that last part. Does that make sense? However, if you did not write your domain, there's points off for saying just all real numbers. Yes? What if this was false? What if this said, what if we solved all the work and we got 0 equals 12? Well, that's false. So what would your answer be?
No.
No solution. Does that make sense? So just remember, true is all real numbers, false is no solution.